Good afternoon. Today to our next webinar. Today we are going to talk about active high available cluster, zero single point of failure configuration, and what are the best practices here, how we can what kind of options we have here, how to configure if we have 1 gig Ethernet, what happens when we have 10 gig Ethernet, and also we will discuss performance practices. So zero single point of failure configuration, we were promoting till now the configuration with bonding and multipath, and that's the configuration, a very well known configuration which is on the chart here. We have made plenty of presentations already, and we have plenty teaching material how to get to this configuration. Next to this configuration, also the multipath should be possible, but because of some misunderstanding we didn't promote the multipath only configuration, which I'm changing now to this slide. Here we have a very similar configuration, but instead of bonding we have just regular adapters. This configuration will be very recommended if all your storage ports, so ETH1, ETH2 and the replication adapter are 10 gig, because when we come back to this bonding configuration, that is plenty ports here, so will be very difficult to get a server with so many ports, and also will be very difficult to get the switch with so many 10 giga ports. That will be very expensive configuration. So if we consider 10 giga, the multipath only is the way to go. And thanks Netgear, there is a 8-port switch on the market available, which is end user price with VAT 750 euro. I was also finding this on the website. I will show you later. Okay, so our setup, we are going to go step by step today, is exactly this one. So with single ports. In my case I have 10 giga Ethernet, but only for replication, and I'm using still 1 giga Ethernet. Then we will be able to show a network bottleneck when we will test such a cluster. Okay, let me go step by step what are what we have as a what is important here. So ETH1 and ETH2, that's are so-called storage adapters on both sides, and on the left side we have a 192.168.1.220 as an IP address. Okay, next is 192.168.2.220 as a physical IP address, and on node B we have a same network, so 1.221 and 2.221, and on top of these storage adapters we configure so-called virtual IP, and in active configuration as a minimum you need 2 volumes. So we have put such a icons iSCSI that we have 2 iSCSI volumes. With active passive it is enough when you have 1 iSCSI volume, iSCSI mirror. Of course you can have more, but for active as a minimum is 2, because first mirror will be managed by so-called first resource pool, and second mirror will be managed by the second resource pool, and we will be able to load balance, means the first mirror set will be active on node A, normally, and the second mirror set will be active on node B. Of course, you can have 10 volumes, and then 5 of them will be active on node B, and then another 5 will be active on node A. Okay, so that's the storage adapters, and on top on storage adapters we have virtual IP addresses, and then the virtual IP addresses on the first adapter. You see on node A I have 192.168.20.100, and that's about target 0. And on the second port I have also 192.168.30.100, and also I'm managing over these two paths target 0, because we will have a multipath, means from every storage client I will go with 2 paths. In my demo I was changing a little, and instead of having 2 ports on one storage client, I will have 4 ports to show the performance difference just from the one node. Okay, so the target 0 will be managed by 2100, 3100, and the next target 1 will be managed by 2200 and 3200, and everything will work over these 2 ports as a storage access. Management access is here. It is optional. If you need, you can, if you don't have enough adapters, you can also use one of the storage adapter as a management port to access the web. But in many cases these adapters are in different network subnet, so and you have mostly enough gigabit ports in the server, so you can use a separate port for to access the web GUI of the storage server to configure this and manage this. Okay, and dedicated connection, so don't connecting to the switch, it is just point to point. That's for the volume replication, and here I can use optionally 2 ports and configure them as a round robin, for example. And if there is no other choice, you can configure this over the switches, but if there is an option to configure this to put the cable directly, then please do it, and this is the most recommended setup. Good. On the storage clients, I will need to access target 0 via 2 IP addresses, so 2100, 3100. Okay, and if I want to access also the second target, I will need to go via 2200 and 3200. So if I have, let's say, Windows client, I can use multipath, the first multipath 2101 as an initiator, and 3101. Okay, that's multipath 1, accessing first target, and 2201 and then 3201, this is a second initiator pair to access the second target. So but again using only 2 ports. In our setup I will show you how I was preparing this. Okay, that's my Windows here, and I will show you how I configure the adapters. That's a local ports, and I have here 4 Intel Pro 1000 PT adapter, and let us see the IP configuration. So the first adapter has a 2101, and also I was configuring this another IP address for ping node. So how to do it? Normally when you go to properties and to TCP IP, that's your first IP address on this adapter, and when you go to advanced, you can add, okay, you can add another IP address. So that's the alias IP, and this single port will be accessed via subnet 192.168.21 and 192.168.1. okay, and that's very easy way to create a ping node. In ASX you will just create a new VM kernel and just assign the IP address. In Xen you can have alias, same as Windows. Okay, so that is our first port. Second port is 192.168.31.101 and also 201 for the ping node, right? Okay, next port I have to configure now 22 and I put 102 IP address, same as I will do it. I will have, let's say, next workstation, and I'm repeating the ping node, so but now is 102, not 101. Okay, and this port has a port 32, 102 and 202. Okay, great. So now we see that the all ports are configured to access all 4 virtual IPs, because my cluster is just configured. We will go step by step, then we will destroy the cluster and configure one more time to learn. But now you see the resource pool on node A. The first resource pool has a 192.168.21.100 and is using a subnet 1 for this, so 1.220.1.221. And the second virtual IP has 3100 and is using 2.220.2.221. So that's the first resource pool accessing first mirror. So in iSCSI resources we see we have a mirror 0, so that's the target 0. Okay. And let us come back to our chart. So you see the 1.220 and 2.220. So 1.220 and 1.221 on the right side. That's the first access path. And here we have a 2100 for the target 0 and 3100. Okay, 2100, 31. Okay, let us come back. 21, 31. Okay, so 2 paths to access first mirror set. And then second resource pool. If you will have just a regular active passive, then this second resource pool cannot be configured. You can have only one resource pool when you have active passive configuration. In active we can define the second resource pool, and in the second resource pool I will have another volume set. Here it shows a reverse because I'm on the node A, and on node B this is a resource pool which is active on node B, and when I will switch to node B, then I will see this without this reverse. Okay, so that's the target 01, and here the IP addresses 2232. So my logic is here 2 is for the first MPIO path and the 3 for the second MPIO path, and the next 2 means second target, and here 1 means first target, and I have also 20, 30 because I cannot start with 10, so I will start with 20. That's the logic. Okay, so my cluster is up and running at this point. When I scroll here, running okay. And in order to get it connected, I need the iSCSI initiator, and iSCSI initiator is connected already. So I have all the targets IP configured in my initiator, so 21, 31, 22, 32. And I have also iometer running already, accessing my cluster. So maybe I will stop for the while, and I will exit the iometer, and I will start iometer one more time. Okay, you see these 2 physical drive. They are my drive which are not formatted yet. Okay, both drives of my cluster, first resource pool 100 giga and second resource pool 101 giga, to see a small difference at once on the size. So I have 4 workers. Let's say first worker is accessing first drive, second worker accessing the first drive as well, and another 2 workers accessing next drive. I can have, of course, 2 workers only, or maybe even more workers. In many cases you should have the 1 worker, 1 drive, but 2 workers works as well. Okay, so 16 is my, I need to switch now and select my server, and then I can put the outstanding number of outstanding IO in the queue, in the SCSI queue, and this is updated for all workers already. So now when I switch to access specification and we create, let's say, sequential writing, so I will do sequential write, and when I have selected a host, then when I click on add, it will be add to all workers, and a result, okay, we can start test here. We don't need to save the results. So because I have in my Windows 4 adapters, okay, because I have 4 adapters, so my performance is about 400 megabytes per second. Why? Because in this chart I put 2 adapters, and it will be almost same situation when I will have 2 storage clients and 2 adapters with multipath here and 2 adapters with multipath here, and when I will start all of them, my total number of megabytes per second will be about 400 megabytes per second. In our demo today, I just have 1 storage server and 4 ports. So 2 ports go over first switch, another port goes over second switch, and I'm accessing a first iSCSI targets on node A, and the second iSCSI target is active on node B. So my first multipath goes to node A, and second 2 cards are writing to node B. Of course, it needs to be replicated each other, but here I have a very good 10 gigabit connection, so my bottleneck will be on the network now. So let us see what happened when I will move activity, everything to node B. So I'm switching now to my setup. So we are writing with 400 megabytes per second speed, and what happened when I click move? So my node A resources are local, so means on node A, and my node B second resource pool is active on remote node, so is active on B. When I move both activity to B, it is enough when I click on the move button here, move to remote, so I'm moving the first resource pool to the remote. Then what happened? Now both resource pools will be active. I need to switch a little I need to switch to last update, okay, then I will see this live, okay, because when it was from the beginning, so it is putting an average value. So now you see we are reaching now when everything is moved to B, so the node A is on remote node and second resource pool is on remote node activity, I mean. So now we are getting 200 megabytes per second because there is no more load balance. All the traffic will go to these two storage ports. Means these two storage adapters, ETH1 and B on node B, is our bottleneck now, and it is limiting us to about 200 megabyte per second. Okay, now when I move it back, so when I move the activity of the first resource pool back to node A, okay, it is moving now, and now it's done. So you see the performance is better because there is no more this network bottleneck, and the first resource pool will be actually physically accessed on node A and the second on node B. Doesn't matter whether I'm writing or reading. If my RAID array is fast enough, then this example show a bottleneck on network, and there is no bottleneck in this test pattern on RAID. In configuration, when we have a bonding, then of course there is more ports, and it is more difficult to show the bottleneck on the network because the more ports are aggregated together, working together, especially when we have a more workstation than one. Okay, so now we see how the load balance works on the two active nodes. Okay, we can stop the cluster now, and let me see if there are any questions. Okay, the first question is, why do you need two subnet for each network interface controller? Two virtual addresses in the one subnet isn't sufficient? Okay, we always recommend to use separate subnet, so the physical IP addresses are in the separate subnet, and virtual IP addresses are in the separate subnet. When I configure, it is much easier to configure everything when when the ports are in a separate subnet. If the ports are in the same subnet, in some cases I will need to put routing tables to make sure that the traffic goes to the proper adapter, because if I have all adapters in the same subnet and I want to generate the traffic from the certain adapter then there is no rules to put the traffic to my destination, to the destination wish adapter. When I have this separated, then the traffic of course goes in the subnet, and I have the multipath working well. Now we will go step by step, and then you will see how I configure this. So coming back to our cluster, so I stopped the IO meter, so let us stop also multipath connections. So see, when I will go to properties, you will see I have 2 sessions in both, and we will configure this in few minutes. Okay, so 2 sessions, I'm connecting twice. I have 2 connections connecting twice. So I will disconnect this. So before I disconnect, I will show you these drives are still there. When I disconnect, so the one drive disappear already, and I disconnect the first one, and the drive disappear as well. So that was my multipath drives, which I was testing here. So now let us remove the connections. So we can go here and just remove. Okay, so I can also remove the favorite targets. I need to do it because when I will configure this now new from scratch, okay, then it will be easier for us to learn. Okay, that's our cluster. We can ping our cluster. Okay, we can ping our virtual IP addresses. So ping 192.168.2100. So it's enough when I'm pinging one of them to show how it works. So it is pinging great, but you see when I'm stopping the cluster, so cluster is stopping now, and I will lose the ping when my cluster is stopped. So the virtual IPs are also out of service when you stop the cluster. So when you start the cluster, the virtual IP address start to answer, and then your cluster is available for your hosts. Okay, so destination is unreachable. Good, so now we have a cluster ready to start, but we will not start now. I will destroy the cluster. So in order to destroy this, you go to volume replication, and these clusters are here connected with a function called host binding. Okay, so here you see I am connected over the subnet 3, which is my replication link. So I just click on disconnect. Please note here we have a tasks. So my local task and my reverse task, so task which is started on node B, still there, but when I disconnect, and also in back to failover, the failover menu is still there, but when I disconnect in volume replication, my tasks will disappear. So I disconnect now. Good, so you see tasks just disappear, and my failover menu is no more available. Okay, so that's the main function to start to bind the cluster. Okay. Next are the iSCSI targets, which are configured so far. Okay, we will not really destroy the targets, or maybe we should. Okay, I can select the first target. Okay, and let's say remove it. I will do it only on one side. And target 0. Also remove it. Good, there is no targets. There are no targets. Our volumes. Okay. If we click on the VG0, so we have two logical volumes defined, and that's the block IO with volume replication on both sides. And first one is 100 gig and second is 101 gig, just to have at once easy to find which one is which one. Okay. How to delete these volumes? Now the delete is unavailable. As long as a volume is connected to the target, you cannot delete, and as long you have a volume replication, you cannot delete it as well. So in order to delete, you will have to click on modify, and on modify you unclick the volume replication and click on apply, and afterwards this will be active and you can remove the volumes, because creating and removing volumes is very boring. So I will not waste time to delete this and create one more time, because creating the volume is just create iSCSI volume. You of course need to select the use volume replication and then enter the size, everything default, and click on apply. That's it. Of course the volume set must be identical size. So the first LV00 is 100 gig on my first node, and on the second node, when I go here and click on VG00, then of course I have a block IO and 100 gig as well. So you see, that's identical configuration. Okay, next step will be volume replication direction. So I click on the volume replication function and need to make sure that my volumes are source. The first one is the source on the node A, and the second is the destination. So when you will just create the volumes, both will look like this, source, source. So you need to switch the second as a destination on node A, right? And on node B, same story. You go to volume replication, both will be source, so both will look like this, and you need to set the first one destination here, because the first one is the source on node A. Okay, that it is. When you have more volumes, let's say 10 volumes, then of course 5 of them will be source on the node A, and another 5 of them will be source on node B, or maybe 4 of them will be source on node A and the 6 of them will be source on B, because maybe these 4 first volume are just the heavy duty volumes, and the volume 5 is also heavy duty, so you need to move some activity, you load balance some activity more to node B. Okay, that's the volume replication direction. And next is host binding. This is available on the both sides, but I always prefer do it on the node A. It is always easier for me doing everything from left to right. Okay, so now I need IP address of my volume replication connection. So please don't make mistake here, and please don't enter this 192.168.0, let's say 221, right? It must be the volume replication link. So in our case 3, and node B is 221, so 3221. Great, so 192.168.3.221, and the admin password is the default, is just admin. If you change the admin password later, it doesn't matter, because this password will be used right now when you are connecting both cluster nodes together, when you are binding them. Okay, there is a few seconds need for the negotiation and exchange of the configuration files. Once you have reachable, you can go to next step and configure volume replication tasks. I prefer using M00 as a name for my first task, and logical volume 0, and here also logical volume 0. I do not find here more because they are different size, and this is why I can see only my volume which from the identical size. Then bandwidth for the sync source. We recommend to use limitation factor of 70%, so 0.7, divide by number of tasks and times available bandwidth for you on your sync. So my sync is 10 giga, so in practice the practical bandwidth is something like 700 megabytes per second. I have two tasks. So let's say 1000 giga, which is the number you can take for the 10 giga times 0.7 is 700, and then divide by 2, that will be, let's say, 350. You don't need to be so strict. In some sources they want a factor, let's say 30%, but we have tested this, and this calculation works stable. And of course you want to replicate in resync as soon as possible, so the good bandwidth should be wanted. Okay, you see my task is defined, so now I can start the task. So I can start mirror of both volumes. Because my volumes were created identical, new from scratch, so they will be in sync at once. If you will have the one volume and then another one created later on, then you will have volume replication syncing them together. Okay, task looks like started. When I go to status and task, I can see the replication stage. Okay, so my destination is consistent. Okay, if you will see that it is something wrong, not available, stop the task and start one more time to make sure that this is consistent, or it is replicating when the volumes were not created, both new from scratch with volume replication at once. Okay, so that's the node A. Let us go to node B and create the task as well. So same story, I'm just selecting M01 here and putting also 350 megabytes per second and starting my M001. So the reverse task is automatically created because we need to replicate once from node A and after failover from node B and so on, and opposite. So now M001 I'm starting on node B, right? Okay, once the task is started, you will need to go to status and task and to see the consistency state. Of course it must show consistent here, so it is still starting, so we need to wait a few seconds. Now it is appearing, and let us click on this and we see consistent. Okay, then we can go to the next step. Next step will be configuring iSCSI targets. So I need to make sure that my targets name are identical. So in order to edit target name, I just removing this checkbox and removing the server name. So that's a great target name. Apply. So I have a first target created, and in my case are two volumes, so I need two targets. So every volume will have their own target, and that's the best for performance. Okay, sometimes I see 20 volumes in one target, and then of course in such case you will have a performance problem. Good, my both targets are created. On node B I didn't delete these targets, so they are created as well. Okay, so this target 0 has a volume attached. I will need to detach this volume. Before we are using plus minus, now we have attach detach, because I will have to put a identical SCSI ID. So when I go to second and detach this as well, okay, then coming back from the left side, I'm selecting target 0, and in this case I will see all available volumes listed. here. So I have two sections selected to this volume, so attached to this volume, and available to attach. So of course, when there is nothing selected, then all my volumes, in my case only two, are listed here. So I want to attach, but before attach I want to copy my SCSI ID. Okay, copy. The best is using such a random number for the SCSI ID. Attach. So this first volume 00 will be moved up to a list of attached volumes to this target. Okay, so now I go to the node B and select target 0. Same story, both volumes are listed here, so I will copy paste, so I will paste my SCSI ID taken from the node A and attach this as well. Great, so both target 0 on the both sides are attached now. So now go to the target 1, and now I will see only one target listed as available, because that's the last not attached yet. So I'm just copy the SCSI ID, attach. The logical number is 0 and it is perfect. Of course the numbers must be identical, but the first logical unit in the target is always 0, so in such case I don't need to change anything. So I'm selecting target 1 on the B as well, and paste SCSI ID, attach. So now both targets are attached with the logical volumes, and the next step will be configuring the failover. So I select setup failover, and now of course many failover menus functions appears, and we need to configure ping nodes and heartbeat path, so or the auxiliary path. So auxiliary path is the first function. We see that the one path is configured already, so that's the subnet 3, so my volume replication connection, because that's best practice and it is strongly recommended to use this point-to-point connection as one of the heartbeat connection, because it's for sure very reliable, and also use storage adapters as a auxiliary connection. So let us go to our chart. That's the 3220 and 3221. That's my volume replication subnet, and 1220, 1221. That's the first storage adapter subnet, and 2220, 2221. That's the second storage adapter, and that's the best path for my heartbeat. So I'm selecting the 221, 221, so both ETH1 in my case. Add. So that's the first storage adapter selected for the heartbeat path. And one more storage adapter. Okay, 2. I can also add the management port as a heartbeat path as well, but minimum are 2 and 3 are fine. So I will go to the next step. Ping nodes. You have seen I was configuring the ping nodes, and I have 4 ping nodes, but let's say we can enter only 2 and that will be enough. So let us imagine that I have one storage client, and then let's say 101 is the one ping node, and maybe 202 will be the second ping node, right? 2 ping nodes is a fine. You can configure 3 or 4, but 1 is mostly not enough. So 101. One, because our first storage adapter is in subnet 1, and let's say this 101 is on our first storage client, and let's say in my case I don't have the second, but let's say I have a second, and that will be 192 168 and second storage adapter and maybe second storage client, right? In my case, both adapters are in the same storage clients because I have just one Windows connected to my cluster. Okay, both are reachable, that's great, and the two ping nodes are also fine. This you can leave by default because that's the best settings. And now we need to define both resource pools. I will start with the virtual IP addresses, so add virtual IP addresses. For the first virtual IP address, I need to select the first storage path. So first storage path are 192.120, 121 on both nodes. That's my storage path subnet. So 192.168.2100, that's my target IP. Netmask, regular class C. Okay, so that's our first storage adapter to access our first target set, in my case one single target, because in our total cluster we have only two targets. Okay, so that's the first virtual IP. Let us configure second, so I will select the second storage path, so on both sides identical, so 2 and 2, yeah, 220, 221, 192.168, 31, okay, okay, that's the second storage path, and to the target 0, so to the mirror 0, so I will have two paths, means I can make a multipath. Okay, now we have defined two storage access paths. Let us select which target will be accessed. So we have two targets, target 0, target 1. Of course, target 0 we know is active on node A, so if I will select target 1, it will be not accepting, because you need to start for the resource pool on node A a target which has activity defined in the initial definition on node A. So I selecting target 0 and apply. You will see the warning error once you select wrong target. And once this ready, we have a first resource pool configured. We have two paths and our one single target in this resource pool. And because we have active setup, then I will also define the second resource pool. I'm staying on node A. I could switch to node B, but I'm staying on node A. And I'm defining first two storage paths. Okay, so first path will go over 1. Okay, 192.168.20, and now 2, because I go to the second target, 100, 255. Okay, that's first storage path to the second target, and then one more storage path to the second target, and we select the second target, and we can start our cluster already. So few minutes more and we are done. Okay, one more IP. So now second storage path goes on the 220 and 221, 68, and now second. So I was always 20, 30. So now 30, and second. So it's 2. Okay, when I have a logic behind and putting the numbers, so I don't need even documentation, and I can always guess what is the proper IP address. You can start, let's say, 51 and 61 and then 52, 62. This is also great logic once you have something what you good to remember. Okay, 22, 32 and iSCSI resources, so we add target, and of course now is only one listed because the first one was already selected. Apply, and that's it with our cluster configuration. Once this is ready, we can start the cluster, and we will see that our ping to the virtual IP will start to answer. Okay, I need to start the cluster. Great. We have ready to start. Okay, so now I'm starting. While it is starting, I will check the questions. Why divide bandwidth when 10 giga is full duplex? Okay, 10 giga is giving you in practice, maybe you can consider maximum like 1000 megabyte per second. I don't think so. That will be easy to get more. So 1000 megabyte per second. That's 1 gigabyte per second. I'm not talking about gigabit. I'm talking about byte. So 10 gig is 1000 megabyte per second. We recommend some limitation factor. So 70%, it means 700 megabyte per second, and I have 2 tasks, so 700 divided by 2 is 350. If I will have 10 tasks, so in such case 700 divided by 10 will be 70 per every task, and this is only limiting the so-called resync. If cluster is running, all tasks are in sync, so everything is load balance is depending on the traffic. Okay, our cluster is started, so you see when I go to oh, I stopped probably the ping. So this is looks like was not my. Okay, now you see I have reply. Okay, when I come back, you see it was not replying, and then from certain point start to reply. Okay, because our cluster is now up and running, and by default the first resource pool is active local and the second is active on remote, means on B. Let us connect now with multipath under Windows. Okay, so when I go to storage manager, see no disks yet. So we need to go to iSCSI initiator, of course, and go to discovery and then discover portal. The first one is 192.168.21 and our target IP is 100. So click OK, and then go to targets. I have this already listed. Okay, I will enter the second path, 192.168.3100. Okay, and now we are ready to configure 2 connections per this target. So I will tell you that of course you need to go to features and configure multipath. You must have multipath configured, and once multipath configured, you need to install on the multipath here. You need to install iSCSI multipath adapter. You will go here and then you will add here. Of course, you must have even fake iSCSI connection in order to do it. So otherwise this is gray. Now it's gray because it's add. When you will have a Windows new from scratch installation, you will need to just connect to any target, then you will be able to add this, and click OK, then it will restart, and afterwards you will see such a iSCSI MPIO driver here. Okay, so first path, I go to connect and I must select multipath, go to advanced, select a first path is a 21, okay, 21 and 21. So my initiator is 2101 on my Windows and my target is 2100, okay? That's the first connection and it is connected already. And when I go to disk management, I see the disk already. But this is one single path. We need to connect one more time. So connect and select a second path. So now 31 on my initiator and 3100 on my target. Okay, so now when I click OK and go to properties, I have two connections, and on storage adapter nothing changed. So I can go to initialize my disk, and when I go to properties, I will see under MPIO that's round robin multipath. Okay, and now let us connect to the second target. Okay, so I go to discover portal 192.168, and now it's 22, 20 because first path and 2 because of the second target, so 100. Okay, and you see it is already appearing here, but now we enter the second subnet, so 192.168 3200. Great. So now we can double connect. So I connect once with first path. So now it is 2202, that's my IP address, and 2200. Okay, we are connecting to this target 2200 using another adapter. Normally it will be from the second workstation accordingly to the to our chart, but we have changed a little. We have 4 adapters in our single server. Okay, so we have one connection. In properties I see one connection, so we go to connect one more time and we select now 32. Okay, the path is defined properly. In properties I must see also 2 connections here. Okay, the second disk 101, let us initialize this. I will not format because the IO meter works with raw disk at once. With formatted disk it will need to create a test file, or I need to copy test file or create test file, so it is for me much faster. Okay, both disks are now created and I can come back to my IO meter and select. Maybe I can use only 2 workers, but I will repeat the same. So first worker is accessing the first drive, second worker first drive, third worker second drive, and the fourth worker second drive. Now I selecting the host and all settings will appear on all workers. So 16 outstanding IO. I'm creating a sequential 64K block and I'm writing like crazy. Okay, I'm putting this pattern here and I'm starting and don't need to save. Okay, and my results are 400 megabytes per second, and if I will now simulate disaster of the first node. Let's say on node A we want to move everything to node B, so now the first node can be, let's say, switch off or shut down. Of course, probably the best will be to set last update, then we will see everything more obvious. Okay, now everything is on the remote node, so first resource is on remote and the second is on remote. This is why our bottleneck now is on network, on 2 adapters on the DSS on the B, because we have 2 storage adapters, just 2 gigabit Ethernet in total. So when we move now first resource pool home, means the resource pool will be accessing Windows will be accessing first resource pool on node A, and the second resource pool will be accessing on node B. Then of course performance is now no more limited by 2 Ethernet, now is limited by 4 Ethernet, so I see a better performance. I was promising here that we will also discuss some best practices how to get a good performance. So mostly everybody of you is familiar with the SSD cache. So today on the market we have a Adaptec and LSI providing option for SSD cache. If you want to have a good I/O performance for databases like SQL or some other, and you really need a good I/O, or for VDI, SSD cache is a very good idea. Also for the VDI you can have a RAID array only from SSD, and in such cases you can have a local SSD based array and connected to DSS, which is also running on VMware as a virtual machine, and using device pass-through or raw device, which we were showing on the previous webinars. You can have a look how to configure this, and then you can have great performance also for VDI, where the application is really I/O hungry. And the low cost, which SSD you need to use. I was finding here a website where you can on the Mind Factory and SSD disk, so Intel, the series 3700 disks are very reliable and a good quality disk, so you can use this for caching. For caching you cannot use just a consumer disk, because they need to have a good write endurance, because caching is even you are reading only and changing the hot data, this hot data will be moved back to the cache, to the SSD, and this is why there is a lot of writes on the SSD. And if you talk about cheap 10 gigabit switch, so there is here example that end user price with VAT in Germany you can buy for 760 euro, and that's the 10 gigabit switch. There is a wrong description. This is 10 gigabit switch. That's the Netgear XS708, and you can have such a chart like we have prepared today, with 2 switches, which are something like $1,500 end user price with VAT. So this is already in low budget cluster, and you can have a very great performance when you're using a 10 gigabit port. So in such case you can have 4 ports, 2 for storage adapters and 2 for round robin, or you can have also 3 10 giga ports. Okay, so let me check if there are more questions. Actually, there is no more questions, so we are done with our agenda for today. So I would like to say thank you very much for joining our webinar, and I will be happy to have you on the next webinar, which is coming soon. So please check our website and you will also get an invitation. So that's it for today. Thank you very much and have a nice day. Bye.